We're told to select all statements that correctly describe this ratio relationship between the circles here and the squares here. So pause this video, have a go at that by yourself before we do this together. And they say to pick two answers. So before I even look at these choices, let's see what we have going on here. We have 1, 2, 3, 4, 5, 6 circles, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 squares. So one way to think about it is, for every 6 circles, we have 10 squares. So let me write that. For every 6 circles, we have 10 squares. We could also write it the other way around. We could say for every 10 squares, we have 6 circles. Or another way to think about it is, because both of these could be divided into two groups. So we could also say for every 3 circles, we have 5 squares. For every 3 circles, we have 5 squares. So we could also say for every 3 circles, we have 5 squares. Now let's look at the choices here. For every 5 squares, there are 3 circles. Well, that's just saying this the other way around. If for every 3 circles you have 5 squares, then it's also true that for every 5 squares you have 3 circles. So I like that choice. For every circle there are 10 squares. No, that's clearly not the case, because for 10 squares we have 6 circles, not just one. So let's just cross that one out. There are 10 squares for every 6 circles. Well, that's just another way of saying what we said up here. 10 squares for every 6 circles. So I like that. And that's exactly what's drawn out here in this diagram. So this last one should be wrong, but let's just double check. For every 3 squares, there are 5 circles. So this is tempting because I see that 3 and 5 there, but it's swapped around. We said for every 3 circles, there are 5 squares. So that's why we would not pick this last choice. But we're done. Choices A and C.